And then we get into the Ozbot. We didn't talk about this year. Okay? I forgot to know. That's this little guy if you haven't seen them. They're programmed by color. They drive over a series of colors, and depending on what 3-color code they hit, it does something. And the colors are literally with a marker. So you draw a red section, a green section, a blue section, and it makes the robot spin around in a circle to the right. And you do a red section, a green section, a yellow section, it makes it spin to the left, and so on. And so they're programmed, you can kind of see this is a pre-programmed card, you can see the little codes maybe in color. They're about the size of a ping pong ball. Right? I asked Sam to bring this one in today just so you could check it out if you wanted to. These are really, really, really neat. And they're programmed, but they're not programmed like a remote. I mean, the kids can all, run the TV remote. This one is programmed using a series of colors on a mat, and you can draw it yourself, or you can use a pre-programmed mat. So they're pretty sweet. Really good abstraction stuff. Those colors mean something to the robot that we would call a language. And so you have this new language to communicate with the Ozbot with. You can tell it, turn your lights on or turn your lights off or beep or whatever by marker. And so it's pretty sweet. I really like this a lot. But it's real limited. It only has 8 different color combinations that you can make it do. And so it's pretty awesome for the kids to try it. Most of you use the Sphero. This would be sort of the next step in that progression. Notice it says it's concrete and abstract, and this is kind of the bridge between the two for me, because it runs like a remote control car. You drive it around and it slams into stuff and things like that. But it also has the ability to be programmed. You can go in and give it commands to create a challenge and hit the button and it will do them. Somebody was talking about Tinker and so on. So it has some programming languages associated with it. I like it that it also has challenges built in that progress from driving to programming. I mean, I don't want to make all this up. I don't have hours and hours and hours to make up all the challenges the kids are going to do. And so you just go through these, and the first one is get your robot to go forward. But eventually it's have your robot where you've programmed it with the touch of a command that it will drive a particular course and light up in a particular way. And so the progression is really pretty good there. So if you want to try that, you can. And we have those. I think we have 15 of them or something laying around somewhere. So
we do.
They're available for checkout during the year. Most of the stuff we do have, I tried not to get too far away from what we own. Lightbot. Lightbot is a computer program thing. Notice the abstraction now. There's no physical stuff anymore. We're not giving them Lightbot. Now they're on a computer. They're working on sequential programming, but it's little bitty blocks. And there's only about 4 commands. There's forward, turn right, turn left, light up. Eventually there's a jump command and so on. So it's pretty nominal stuff. So you don't have very many choices. It's simple, but it's virtual behavior. It's tell it to do it and then it'll do it. Plus it's free, which is really nice. So if you've never used Lightbot, it's a really nice thing to do. And again, it's sequential. There's level 1s, there's level 2s, there's level 3s. So I always kind of stop when you get to these loops and procedures part, because that's real programming. That's honest to gosh, become a computer programmer language, and they're right there. Now they're real easy, okay, but it's a great way for kids to realize how programmers work and think and program. So I really like Lightbot a lot. And it doesn't cost anything, which is nice. And then the cubelets that we got a chance to play with already this week, same thing. Notice I jumped back to concrete again, because now I have more commands, so I don't want to stay in the abstract world. I want to come back to physical manipulation again, because I've got lots of choices now. I've got inverse boxes, and I've got boxes or blocks that make things spin and make things light up and roll. And because I have more choices now, I have brought my kids back down to something that has a more concrete feel, and they can physically put it together. And I'm constantly kind of wandering between that and so on. This has a level built in though. You can do the little put them together things. You can use a language called Blocky, which is a computer programming language that you use your iPad for, and you literally program the blocks to do things, all the way up to C, which is a professional programming language. It's actually C+, and it's a typed language. It has no blocks. You type in computer commands and it does stuff, and you could program the blocks with that. So there's really young, just getting started, all the way up to college level MIT kids that can program this thing. And so I really enjoyed that a lot, and it really does a nice job. And notice it talks about trial and error there, and that was important because we want kids to be able to try something and fail without spending an hour on it. That was one of the problems with the VEX robots. They take so long to put together that when they don't work, you've invested a lot of time to just not get it to work. With the cubelets, it took you 4 seconds to put it together. It didn't work. It takes you 1 second to take apart. You're only 10 seconds in total. You're good. Hour of code, most of you have used, and the idea here is we're going back into abstract, but now we have lots of choices. The best part of this is that the progression was done by professionals. It's terrific. They start with move the sheep, then it's move the sheep and make more sheep, then it's move sheep, sheep die, whatever. And so the progression is pretty sweet, but it's not real anymore. And it helps kids get into this idea of abstract thought. It does a really nice job. And it's got all the programming features from loops to what are called if-then statements or conditional statements. And so it is really professional programming at a very easy level, what we call that idea of abstraction. So it's awesome. Plus they're themed now. So there's Minecraft and Star Wars, which are the ones I've used, but there's also Frozen and a Disney one now and so on. So there's enough different ones that the kids can get in there and play. And they're free, which is pretty sweet. I won't bore you, most of you. And then finally, you can get into something like Scratch, which is an open programming language. It's programmed with the exact same blocks you use in Hour of Code. That's why I like it. They look the same, their layout's the same and so on. But if you start with a blank screen, you bring in whatever actors you want. They're called sprites, and you put them on the screen. So if you want a ball, if you want a cat, if you want a vampire bat, you bring in the image and you program its behavior, and they're literally called scripts now, because you're actually putting in scripts and they're called behaviors and so on. So this is a professional programming language made by MIT. Again, it's free. The cool thing about this is they have some samples done for you, but the samples are in that programming language. They're not easy. It doesn't walk you through them that much. There's only a few walkthroughs. And so you have to get there through Hour of Code. I wouldn't just jump into it. The background's too hard. But it's awesome. And you get to share. So if somebody makes a really good one and they put it online, I can look at it. I can not only look at their game they made or their experience they made, but I can look at all the scripting behind it. It's all right there. I can even edit it and make it my own. And so that's really one of its pluses. It's very kumbaya, we all learn together kind of stuff. And then finally we get into Mindstorms and Vex and things like that, which are sort of the pinnacle of all this. But notice we actually went back to concrete stuff again, because the idea is that real world. I mean, we don't build robots to do stuff in Lego Mindstorms land. We do so here to get into caves, to check the surface of Mars, to do surgery. If we have the world's best surgeon, but he's in Venice, Italy, it doesn't do us any good if we're in Indianapolis, unless we have a robotic surgery unit. And he'll move things, or she'll work on a surgical implement in Venice, and in Indianapolis, the things will physically happen. Okay? And through cameras and through virtual devices and through VR things, we now have people that can perform surgery on a patient that's thousands of miles from where they are. And so that's where this is going. Notice I did put failure as frustrating and time consuming, and that's its drawback. If your kids aren't ready to do this, you're just going to torque them off, and you're going to frustrate you and them. And so you have to start where you know they're going to be successful. Don't give them a challenge right away. Start with ease and success at whatever developmental level your kids are, regardless of grade, and go from there. And that's kind of what I kind of wrote this little note here. So you have to decide how complex and abstract your students and will enjoy and succeed with. And there's just some little notes. So start low and work fast. So the first thing is make sure the stuff's easy enough for them to do and that they can do it quickly, because you're going to frustrate them if they take an hour and it doesn't work. Start easy. It talks about success breeds interest. If your kids are constantly failing, they're not going to want to do it anymore. Okay? It doesn't mean you can't challenge them later, but they have to have some successes to fall back on. I can do this. Not, I've never got this dang thing to work. Okay, that's going to start with the concrete, okay, because they already have experience with the real world. They know when it drives off the table what's going to happen. And so it saves you a lot of trouble there. I put a little thing about keep the carrot moving, and this goes for what Mr. Pitcher was talking about. You've got to be learning and playing and experiencing too. When my kids built those roller coasters, one thing I did well was I built a little bitty one over here so they could see me fail too. It's like they won't see the educational failures I ran into. They don't know scope and sequence and things like that I didn't do right. Okay, they just knew that things were moving along, but they could see that my roller coaster didn't make the loop-de-loop either. Okay, and so that was important. So you've got to be the model and the learner as well. So it helps for you to have stuff to play with. Okay? And it's okay. There's a little Elon Musk quote down there that talks about if all of his employees are succeeding, he would be pretty disappointed. And so it talks about innovation and so on. So that gives you some idea of what you can do this year with all the big picture stuff. As you want to implement this with your classes, you've got a chance to do so in a purposeful, planned way, not just what we'll call organized play. Because I did that and it was fine,